And then we come to the contextualized question. So we're right up now to an A-level standard exam question. A characteristic of the shape of a human skull is measured by a number n. People are classed into three groups. A, for which n is less than or equal to 75. B, n is between 75 and 80. And C, n is greater than 80. In a certain population, the percentage of people within these groups are 58%, 38% and 4% respectively. Assuming that n is distributed normally within this population, determine its mean and standard deviation. So they're telling us that it's a normal distribution. They're not telling us anything about what its mean and standard deviation are. So let's work with that first of all before coming back to the second part of the question. So it's giving me three groups. It's telling me that A, the probability of n being less than or equal to 75 is 58%, 0.58, which gives me this distribution here. The area is over 0.58, so I can assume that it's this side of the mean. Then I'm being told that B, the probability that n is between 75 and 80 is 0.38. And finally, they're telling me C, which is the probability that n is greater than 80, is 0.04. I've got two unknowns. I need to find the mean and the standard deviation. I don't need those three sets of information, and the two that are most used to me are the two which give me the extremes at the end. So if I map this one onto Z, so mapping that one onto Z and working out A, I can then transform it onto the previous one. So menu 7, 3, 0.58 gives me A as 0.20. Say 202, let's go to 3 decimal places. So using that and then mapping that on, so now 0.202 equals x minus mu over the standard deviation. So rearranging that, I get mu plus 0.202 sigma equals 75. Call that equation A. So I'm going to store that value in A. Now I'm going to map this one. And remember, with this one, what I'm going to get off my calculator is minus a, because it gives me the less than value. So back into the inverse normal, and the area now is, don't know why I put minus 0.04 there, 0.04. So that gives me minus 1.75, which means A is 1.75. So putting this information into the transformation function, I have 1.75 equals 80 minus mu over sigma. So mu plus 1.75 sigma equals 80. I call that variable b. So if I store that in x, come into the arithmetic screen and put minus x into b, that means I'm storing the positive value now. So I want to figure out what, so to eliminate from this, I can eliminate mu by subtracting. So if I do b minus a, because that's bigger than that, that's bigger than that, I will end up with, so get that light out, so b minus a tells me I've done that minus that, and I get 1.549 sigma equals 80 minus 75, which is 5. So the standard deviation is going to be 5 divided by that, 3.23. Then if I sub that in, doesn't matter which one, A, then mu is going to be 75 minus 0.202 times the standard deviation, which we've got there. So mu equals 75 minus 0.202 times the previous answer, which is 74.35. Okay, so therefore my normal distribution n has got a mean of 74.35 and a standard deviation of 3.23. Let's go back to the question. Determine its mean and standard deviation. Right, we've done that. 3 people are chosen at random from this population. Determine the probabilities that each of the 3 has a value of n greater than 70. Well, first of all, we've got to work out what the probability is of one of them having a value of n greater than 70. So on our normal distribution, now we're going to go back into it, but this time we've got the normal cumulative greater than 70. So if we do a little sketch over here of what we're working with, we now know that the mean is 74.35. So the probability of a skull being measured greater than 70 is this. So that's my lower boundary, and then 1 times 10 to the 99 is going to be my upper boundary. So lower boundary 70, upper boundary 1 times 10 to the 99, standard deviation 3.23, mean 74.35. So the probability of a head being measured greater than 70 centimeters is 0.918. 1. So each of the 3 is going to be probability n greater than 70 for the first one, and n greater than 70 for the second, and n greater than 70 for the third. So it's going to be 0.911 times itself 3 times cubed. So if I store that in x, back into the arithmetic land, x cubed 0.76. So you've got a 76% probability that all 3 of them will have a skull measurement greater than 70. And then part 2, at least one of the 3 has a value of n less than 70. So you could start doing a nice complicated tree diagram here with greater thans or less than, but usually one question leads from the work that you've done in the previous one. And for at least one of the 3, then that is any outcome apart from all of them being greater than 70. So at least one of them being having a value less than 70 is just total probability 1 less the answer that you had for the value above. So that's going to be 1 minus 0.76, which is 0.244. So there you go, you've certainly got a decent A-level standard question in that example.